Okay, Doppler effect time. We're doing number 5. This is going to be a little longer. The other ones will move through a bit quickly. This unit is super easy and straightforward. You use one formula the whole time. They're just going to give you different variables. Or they're not going to give you different variables throughout your whole thing. So, number 5. One foggy morning, Ken is driving a speedboat towards the Brent Point Lighthouse with a speed of 15 meters per second. As the foghorn blows, just a horn, with a frequency of blah 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 hertz, 180 hertz. What frequency does Kenny hear? Step 1, we write our formula down. Flip back to the page if you don't know. The formula is right here. Okay? So the perceived frequency, the frequency perceived, I'm just going to put a little p there. Oh, let's fix this. Equals the actual frequency times the speed of sound. That's the velocity for speed of sound. Plus the speed of the observer over the speed of sound minus the speed of the source. What's causing the sound? So, first question is, everybody's like, well, what do I put for V? Like, they don't tell you. Remember, the speed of sound is a constant. So if you just look up a little bit on this page, what do they put for V? Speed of sound, 340 meters per second. So that's what our V is. Right? So let's do some stuff on the side. First off, what is the speed of the observer? Let's put our stuff on the side. Velocity of observer equals, well, that's Kenny, 15 meters a second. 15 meters a second. What's the velocity of the source? Well, the source is the lighthouse. Is the lighthouse moving? No, it's just sitting there, right? 0 meters per second. So we've got the velocity of the source. We've got the velocity of the observer. What's the velocity, the straight up velocity? So that's our speed of sound. Well, we know that from up here, 340 meters per second, right? Bam, bam. Okay, so now we've just about got everything we need. And then the actual, excuse me. The frequency, yeah, the actual frequency is 180. 180 hertz. Dang, so we got everything we need. So now let's plug it in. So the perceived frequency equals, you guys remember the actual frequency? 180, we wrote it down on the side, and then times, assumed, speed of sound, 340, plus speed of the observer, which is 15 meters per second, right, over speed of sound again, 340, minus the speed of the source. Well, the source, again, the source is this lighthouse, which is not moving, so that's 0. Okay? So, let's further reduce it. So, the perceived frequency equals 180 times, what's 340 plus 15? 355 over 340, because minus 0. So the perceived frequency is 187.94 hertz. Let's think about this. What's the actual frequency? Right here, 180. This is the lighthouse putting it out. Right? Putting out its frequency. He is going towards this frequency. So yes, he's going to perceive it as a higher frequency. because he's going towards it, right? So that's why our actual frequency is 180, yet he perceives it as 187.94 because he's going towards it. So that makes sense, right? This was a lower number if you didn't know which direction he was going. But this number was, let's say, 150. That tells me that he would be going away, right? He would be going away. But we know he's speeding toward the lighthouse, which means it should be a higher frequency that he perceives in his head. So there you go. So we got our answer, 187.94 hertz. And that's pretty much sums up every one of these problems. They're going to give you all but one of them, whether it's this, or one of these, because you know the speed of sound, so that you're always going to have this, right? And that's it. The only thing you need to worry about with these is sometimes it trips you up if you have to make this a positive or negative, because it depends on the direction that they're going. So what do I mean by that is this right here. So the velocity of the observer is positive if he's moving towards the source, negative if he's moving away, and then the same thing for the source. The source moving towards the observer, positive, away, negative, okay? So that's the only thing that's going to trip you up, if it's moving towards you away. And just remember, when you do get your answer, just think logically. You don't have to know all the numbers to know that, your frequencies will be higher or lower depending on the things going towards or away. Makes sense, right? Alright, so there you go. There's number 5. Super long example, but we got it.